All right. Good morning, everybody, and good day to everybody, those who are coming in from other parts of the world. As you know, this semester we are offering a joint seminar series with CIB, broadcasting here live from Purdue University. And the theme for this semester, as you know, is women researchers in the built environment. And following that theme, today we have another distinguished speaker with us today, Dr. Fernanda Leite. She's the Associate Dean for Research in the Cockrell School of Engineering at the University of Texas at Austin. She's the past chair of a university-wide Bridging Barriers research initiative called Planet Texas 2050. Most of her research has been in building and infrastructure systems, information modeling, scan to BIM, visualization, and collaboration technologies, and circular economy in the built environment. At the University of Texas, Dr. Leite has taught courses on building information modeling, project management and economics, construction safety, and sustainable systems and engineering. She carries a very busy schedule, so we are very happy that she could take time out and give this seminar to all of us. So over to you, Fernanda.
Thank you so much, Mark, and thanks everyone for inviting me to be part of the seminar series. So I wear multiple hats, but I'm here to talk about my research program. So I'll give an overview of my research program and talk about 3 example representative research projects. One of which is the one that Mark mentioned that was part of this broader cross-disciplinary initiative called Planet Texas 2050. And then I'll make sure that we have some time for Q&A in the end. So my home area within civil engineering is in construction engineering. So we're part of the Kumar Construction Engineering and Project Management Program. And we're 6 core faculty members in this program. We have several also adjuncts that help deliver teaching to our students, which are professors of practice, but these are our core faculty members. So John Borschening has been in our program since the 1970s when Richard Tucker founded our program. Carlos Caldas has been in our program for about 20 years now, working on front-end planning and construction productivity. Casey Faust, it has been with us, and she's a Purdue alum. So she worked with Dulcie Abraham out of Purdue, and she does water infrastructure modeling in our program, and humanitarian engineering. Bill O'Brien has also been with us for about 20 years, and he does mostly supply chain management, advanced work packaging work, and he's now wearing 2 hats, also working with CII and their technology committee. And Chris Rauch is our newest faculty member. So this was a new hire. Jim O'Connor, who had been with our program for 38 years, retired last year, and we hired Chris Rauch. He finished his PhD out of the University of Waterloo with Carl Haas, and he does industrialized construction and modularization work. So it's pretty exciting to see this group of people here working to make this program even better. So we're really proud of our alumni network. We currently have around 60. I didn't update these numbers, but these are we have about 60 graduate students. This is just master's and PhD in the construction engineering. So this is again one area within civil engineering, and we've been trying to increase the diversity also of our student body. We have about 22% female students. And we're really proud of our alumni network. We have over 800 alumni from 58 countries around the globe. And we continue to stay engaged. This is one of our annual events, our golf tournament that we host every spring. And we also have our alumni newsletter that I edited for 14 years. I just passed on the baton. I think Chris Rauch is going to be doing that from now on. But it was always a pleasure for me to interact with alumni as I featured different alumni for that newsletter. So we were talking before the seminar started that this week was very significant for our Department of Civil, Architectural, and Environmental Engineering because we were named the Faribault Massey Civil, Architectural, and Environmental Engineering Department just this week. And so this is a once in a generation investment in our department, and it will be focused on really changing how we deliver civil engineering education, and it will really impact our curriculum for the next 50 years. So this is a very large department. So we're about 55, 56 tenure track faculty members, about 1,500 students in this department, and we're divided into 10 areas. I'm affiliated to these 2 areas that are in bold. So my home area is construction engineering, but I also created and was the first area coordinator of our cross-disciplinary area called sustainable systems engineering. So this area, the idea with sustainable systems is that we're doing cross-disciplinary work, and all of those students interact with faculty they co-supervise with faculty from at least 2 of these areas, the traditional areas in our department. So most of the students in the sustainable systems program are research focused. So lots of PhD students interested in interdisciplinary research, or master students with research. We are also heavily involved and heavily connected to the Construction Industry Institute that celebrated its 40th anniversary this year. So CII was founded by Professor Emeritus Richard Tucker, who also founded our construction program, and that was founded in 1983, and Richard Tucker served as CII's first director. So I actually had the opportunity to visit Richard and his wife Shirley Tucker just this week in their home here in Austin, and he's doing quite well. He also attends our golf tournament every year. So what is CII? So CII is a consortium of over 100 leading owner, contractor, and service providers. So the idea is that we bring together subject matter experts from industry with researchers that understand research processes, and together we can improve the capital projects industry. So the original intent of CII, or focus area of CII, was safety, and they did have a significant impact in construction safety across the industry. CII member companies tend to have better safety records than non-CII member companies, but these are leading organizations. But now CII has a broader breadth of focus areas as well, and many faculty member in construction engineering, several people here have been involved in CII research or different CII committees. So the mission is to provide a research and development platform, and to create and drive innovation across the construction industry using a very disciplined, academically based approach. So for context, CII is one of 17 organized research units within the Cockrell School of Engineering. So now in my new role, I'm having to do a lot of homework and learn a lot about all these other 16 organized research units. So I would say CII is not even the largest one. It's about the mid-level in terms of size. So there's quite a variety there of different research centers that are part of the Cockrell School, which is the fun part of my new job. And one thing that I have been focused on throughout the years is virtual design and construction. So I've taught a BIM course. I created this course at UT. But when I first started here at UT Austin, I taught it for 14 years. And again, this one was a hard one to give up for me, but I had to give this one up. Chris Rauch will be teaching it moving forward. I did publish a book around this area that I use in my course, but it's something that I'm really proud of, and that we helped integrate building information modeling across our architectural engineering undergraduate program when we started this course. So it's not just part of this one course that we focus on construction, but it's also part of the sequence of design studio courses that are required in the architectural engineering program. And this course is actually half undergrads, half graduate students. It's entirely project-based. You're seeing a lot of photos of students visiting construction sites and people from industry leading sessions. It's very hands-on. And so we do have a lot of involvement from our alumni network that come back and lead sessions, lead interactive design coordination, mock design coordination meetings, different demos, guest lectures, site visits. And it's quite a popular course, and our students, we really wanted to make sure that it stayed, even with my transition out of the program. Okay, so my research program is focused on the built environment. So most of my work is at the interface of engineering and computing. And I would bucket my most recent research into two main areas. One is building information modeling and construction technology, or in a broader sense, virtual design and construction. And then the second bucket, which is my newer, I'm leaning more towards this direction in my most recent and future research, which is information modeling in sustainable systems. So I'll give you a little bit of an idea of what all these research projects are by giving you examples of three of these projects that I'm heavily involved in. Which is the LivingBIM project, virtual reality for construction, and Planet Texas 2050, which then led to other newer funded projects. But before I get into these example projects, I wanted to acknowledge my current and past students. This is probably the best part of my job, is working with such motivated and smart people. I couldn't do any of this work without all of these great people that I work with, and that I'm so thankful to be around and to have in my team. So you'll hear a lot of the work that I'll be presenting today are from the students that the names are bolded. So some are recent graduates, some are current PhD students in the work that I'll be presenting. But I'll highlight their names as I present the work here. So let's get started with the first project here on virtual reality for construction. So this was a CII funded project. It was commissioned by CII. We were commissioned to develop a guidebook for virtual reality in capital projects. So what do companies need to know if they want to create a virtual reality team to support capital projects delivery? The PhD student that worked in this project was Bing Han, and he's now an assistant professor at the University of Colorado at Denver. So the nice thing about this is we had quite a bit of freedom beyond that guidebook that presented an idea for us in terms of okay, we can develop this guidebook of how to implement virtual reality, but for us it's also important to understand when that technology makes sense to be used. So we looked at different use cases with our research teams that would apply or would be best suited for this type of technology. And we delved deep into two specific use cases. One was planning for advanced work packaging, and another one was design review. And then we actually did a series of user tests when we were developing the work. So this is a picture of a subset of our team. So we have representatives from Zachary Corporation, from Fluor, from Black & Veatch. And this was when we presented at the 2019 CII annual conference in San Diego. The person here on the right is actually my daughter, who has attended a bunch of talks that I've given throughout the years, some of my classes, and she, as all a young generation, is really easily adaptable to new technology. So this is her playing with our demo here at that conference. She's a little bit older now. She's 7 and in second grade, but that picture was, she was about 3.5 when that picture was taken. So ENR was there in that 2019 conference, and they wrote up an article about the work that we presented, and the headline read, "CII study finds virtual reality helps reduce design errors." So I also like to explain what that means and how we came about to be able to explain that conclusion there. So what we did in the study as part of that CII study we developed a series of user tests in which we had about 90 subjects, and we split them into two groups. So half of them were experts, so people with 3 years or more of heavy industrial construction experience. And the other half were novices, so less than 3 years of industry experience. And then within each of those groups, they were either put into a control group, which they were interacting with the same exact liquefied natural gas plant model in a desktop via desktop computer. And then a treatment group, which was a group of people that were using a virtual reality headset to also walk the model. So all of these groups, they did the same exact task. They walked the model virtually, and they were told to identify a series of design errors as they were walking the model. So an example of a design error that we had planted in the model artificially so they could find it was this, for example, the support structure that doesn't quite reach the height of the pipe spool, the bottom of the pipe spool, so it's not really providing support for that pipe spool. So this is an example of a design error that you could not automatically identify via a clash detective tool, so you literally had to walk the model to identify. So these would be examples of false negatives if you're doing automatic clash detection, but you need to walk the model to find. So there are several of these. And what we found was that for the novice groups, they identified more than twice the number of errors when they were navigating the model in a virtual reality environment using the virtual reality headset. The expert group wasn't quite as drastic, but it was still statistically significant, that difference between interacting with that information in a desktop scenario versus virtual reality headset. So what this tells us is that, well, perhaps we can leverage this tool to train our next generation engineers to perform design coordination more effectively by providing these examples, and they can learn a lot faster in terms of design coordination. We also see that experts also benefit from being in the right angle, looking at that information from a realistic standpoint, a realistic vantage point. They can actually identify more errors from that perspective as well. So it benefits everybody, but we can really leverage this technology for training next generation engineers. So Bing, after that CII project was over, he continued that work, and he developed an approach in which we looked at how much model preparation time was spent to prepare these models to be used for a specific use case. For example, design review in a virtual reality standpoint. Well, if we had to take that same amount of time for every new use case that we were implementing, that is one of the major barriers for implementation of this type of technology in construction sites. So we wanted to create an approach in which we had a generic extended reality model that could, or a framework, right, that we could then send that model to either be used for mixed reality, for augmented reality, or for virtual reality. So the model preparation time would be drastically increased, and you could diversify the number of use cases that you would be using that same base model for. Bing was also involved in one of my Planet Texas 2050 projects with another PhD student, Danny Weeks. And this was a very cross-disciplinary team. You'll learn more about Planet Texas in a bit. But there are representatives here from the College of Fine Arts, Entertainment Technology, our supercomputing center at the university, which has a visualization lab, and engineering. So we developed a storyboard and integrated results from other Planet Texas 2050 research into this simulation, simulation. So the idea is that we would be able to engage the broader community in scientific research in unique ways, as opposed to what you're seeing right now, right? You're hearing me speak via PowerPoint presentation. Another common way is to read papers or a poster presentation, but we wanted people to interact with research results. So that's what this Texas Futures virtual reality experience was all about. And this was also just a very fun project to be part of. So we had several publications that came out of this work, and I'll highlight I'll highlight an interesting one that's not an academic per se publication, but we really like engaging with the broader public. So we worked with the Science Journal for Kids, and they translated. So this paper here that was published in the top left-hand corner of the Measuring the Impacts of Immersive VR, that paper was published in the Journal of Construction Engineering and Management. So we took that journal article and had the Science Journal for Kids translate that for middle schoolers, and they developed all of these graphics and images, and some simplified the way that we deliver the results, communicated the work in a different way, and that was pretty neat to see that communicated that way, and then created an educational module for middle school teachers to use. And we've already been getting feedback from middle school teachers that have been using this module in their classrooms. So the second project I wanted to talk about, and this is still something that's ongoing. This was initially funded by the National Science Foundation, and I like to call LivingBIM was a poetic title when we started this proposal. So the idea with LivingBIM is that buildings and infrastructure systems, they're like living organisms. They change throughout their life cycle. So that's why we called it LivingBIM. And the whole idea is to develop an approach to automate the upkeep of these models. So that we can then decrease the barrier of their use in the longest phase of the project lifecycle, which is the operations and maintenance phase. So two students, past students, worked in this project when it was funded by the National Science Foundation: Jungwon Ma, who's now at Concordia University, and Thomas Cherniawski. And now I have a third PhD student, Abdullah Al-Suhaibani, who's working on the next phase there of the LivingBIM project that I'll tell you about. So the whole idea started with, well, we have this need to maintain these models up to date so they become useful and they don't become obsolete. However, we're spending quite a bit of time, facility operators are stuck having to redo a lot of information and manually update these models, or manually search for whatever information they need when a building renovation is happening, or when they need to pull the most accurate information on a model. And with this idea of, okay, buildings are like living organisms, they change throughout their life cycle, we need to come up with an approach that removes the human from the equation per se, and so that we can then automatically perform these updates. So we leverage an approach that combines 3D imaging, semantic segmentation, and model federation in this project. So the idea with 3D imaging there, we could have gone with sophisticated laser scanners, but we wanted a low-cost solution that any facility manager could use. And when we started this project, our cameras, I'll show you here on my phone, right? Y'all probably have phones that have at least 2 cameras, some 3, and that one of those cameras is a depth camera. Right, so it captures that. That's how the iPhone gets those fancy, portrait mode photos. But back when we started this, these smartphones didn't have depth cameras embedded in them. So we had used a sensor called a Structure IO on an iPad to collect that depth information. Now we can just do this using iPhones. So we collected these 3D meshes. Then, with the help of many undergraduate students, we manually semantically segmented these 3D meshes into objects that were labeled, like you can see here. And we use these labeled semantically segmented meshes to train deep learning algorithms to then classify other meshes on their own in the future. So the way that we do this is we use an approach called transfer learning. So we had that initial large data set of several meshes. I'll go into the details of how many. And that was published in a database that is publicly available. Anyone can access and download our data. It's called 3D Facilities. I'll have a link to it in a bit. But we couldn't just use our data. Our data is a specialty data set, so it's mostly building systems, MEP systems. But we use transfer learning in that we built on existing data sets that were already publicly available and also semantically segmented. And this includes Microsoft Cocoa, Pascal 2, ImageNet. So they include general objects from the built environment that you don't really need expert knowledge to be able to classify, like, for example, doors and windows and tables and chairs, right? So any human could understand how to classify that. Now it'll be a little bit harder for the average person to classify what a sprinkler head is and what a diffuser is in a building in a 3D mesh. So that's why we're building on top of existing data sets using transfer learning. The computation, we run our models in our supercomputing, which is a center, which is called TAC, the Texas Advanced Computing Center. So this is the largest supercomputer in any university in the world. I know that several universities keep fighting. Every year we upgrade our systems, and the rankings change, but we're still there at number 1 right now. And then we also use open source algorithms to build this work. So in this case, we use TensorFlow. So 3D facilities, this is published. This is the link. It's published in Zenodo. It's a database of 3D annotated 3D reconstructions of building facilities. Like I said, a specialty data set, mostly of MEP systems. This data set won the inaugural American Society of Civil Engineers Data Sensing and Analysis Committee Best Data Award in 2022. And we continue to expand on this data set. Now with the new PhD student, Abdullah, he's creating a new data set which we're calling LivingBIM. That's the same idea. It's a 3D semantically segmented data set for a building that actually has ground truth data, the BIM model with the data. So we're trying to now, instead of what we're doing here of training the data sets with 2D data, and I'll show you how, but we're trying to develop an approach in which we're training our models with 3D data. So 3D facilities, when you go into Zenodo and download the data, what it actually contains are 110 scene reconstructions, and they're semantically segmented. Each of these colors means a different label. But what we actually use to train our models are 2D projections of those 3D meshes. So those 110 scene reconstructions when projected into 2D space, that becomes 25,000 individual RGBD frames. So color and depth, red, green, blue, and depth. So that's what that means there. So this is what actually the algorithm takes as input. And that's what this new work that we're trying to do is to, instead of having the step of doing the 3D to 2D to training the algorithms, we want to go from 3D to training the algorithms. But in the LivingBIM project, what we initially began training our algorithms with only color data, then we added depth, and then we added also IMU data, so to give an idea of what direction we're looking at and when that image was taken. So the big contribution of this work was that in the end, we're able to automatically classify 13 different classes of objects in the built environment. And this is more than double what any work had done before that in the built environment. So this was quite significant. That's why this work got a lot of attention when we published this. So we published a lot of different papers in this area, mostly in automation and construction and advanced engineering informatics. We still have work coming out of LivingBIM, and these will be coming out soon. So the last research project that I wanted to talk about today is Planet Texas 2050. So like I mentioned before, this is a very large cross-disciplinary research initiative. And it's one of 3 of these large initiatives that are happening in our campus here at the University of Texas at Austin. So Planet Texas, and they're all about 8 to 10 years in duration. Planet Texas is focused on resilience research. So we're looking at the impacts of climate change and population growth in our cities and infrastructure systems. Whole Communities, Whole Health was a second program to be launched, and that's a longitudinal study of health in a vulnerable community in East Austin. And finally, Good Systems. That one is focused on ethical artificial intelligence. So a lot of people ask me what Planet Texas 2050 means, the title. So the idea is that what's happening here in terms of climate change and population growth is what we can learn about what's happening here and apply it to trends that we're seeing globally as well. And 2050 is the year that the population in the state of Texas will double compared to the year that when we launched as a grand challenge, which was 2018, which is quite significant. There's a lot of influx of people in the state of Texas because of all of the industries and jobs that we have available, the energy sector, technology jobs as well. So that puts a lot of stress in our infrastructure systems, which we have to then come up with sustainable solutions to deal with these challenges. So each of these 3 grand challenges, we operate like a startup. So we do get internal funds, so about 10 million per grand challenge program. And the nice thing about it is this is fringe-free, overhead-free. So it goes quite a long way compared to, let's say, your traditional NSF grant with full overhead and full fringes. So it's not just that startup funds that we get that matters. Actually, the most important thing that we get is the support from the Office of the Vice President for Research in terms of proposal development, fundraising, industry relations with external partners, event hosting and logistics. We've hosted an NSF-sponsored workshop on resilience research to action that the entire logistics was done out of this group, and also communication. So there's staff writers that help us disseminate our work to the broader public as well. So a lot of Planet Texas 2050 researchers write op-eds, we give interviews, we interact with the press to really put a spotlight on this kind of research that's happening here at the university. So the focus here is looking at environmental shocks and stressors in Texas metropolitan areas. We use remote sensing and field studies to predict environmental change. We also leverage artificial intelligence-enabled model integration and decision support in these predictions of what's going to happen in the long term. That several of the researchers are also doing complex interactions of human and environmental systems. And we also have a group just focused on climate justice and community engaged research initiatives. You can learn more about Planet Texas 2050 by going into our website. There's videos, there's lots of materials on our different projects. And this is to give you a sense of the scale of this, and this is one of the 3 grand challenges. We've had over 145 researchers in this university involved in this grand challenge initiative, and they come out of 40 different departments and units out of the university. And we do have also external partners beyond just the UT crowd, and these are a variety of institutional partners and NGOs and industry as well. So like I said, we operate like a startup. So we have a leadership team that sets the direction of the research. And like you can read this quote here on the right of our former president, university president, of why this initiative was launched. But the gist of it is that we really wanted to change the culture across the university to do more cross-disciplinary research. And one way of changing that culture was making this initial investment to put people in a room together to solve a wicked problem or to work towards solving that wicked problem. And that would then lead to new research initiatives. And I'll show you some of our successes that we've had so far. So I served as past chair of Planet Texas 2050, and I just rolled off the leadership team given my transition to administration. So we started off with about 24 funded projects in Planet Texas 2050 for the first 2 years. Then we transitioned into what we're calling our 6 flagship projects. These are long-term investments that we make in these projects. All of these are very cross-disciplinary. The one that I co-lead with a colleague in community and regional planning is the one here in red, equitable and regenerative cities in a post-carbon future. So for this flagship, we're looking at how can we co-design with our community partners equitable and regenerative cities. So this idea came from circular economy. And some of you may have seen the work that I've done with the Construction Industry Institute on circular economy applied to the built environment. Well, here we're also implementing the same concepts, but applied to urban systems. So if you've never heard of circular economy before, so think about it's a shift in mindsets from a traditional linear economy in which we take, make, use, and dispose of products to a circular economy, so we can keep products online for a longer period of time. And the idea of waste should actually be shifted towards resource. So waste can become a resource. So one way, there's a lot of companies that are implementing circular economy now. A simple example, we all have smartphones. If you take your smartphone and you want to upgrade it to a new one, you take it back to your iPhone, or let's say Apple, right? Or your phone manufacturer, and you get a little discount on purchasing your new phone, the latest version of your phone. Well, what they take then is they take that old device, they disassemble it and use all of those pieces and parts, or reintegrate those pieces and parts into the supply chain to create new products. So the fashion industry has also been doing this. So Patagonia is one that you can return an old garment, and they will use the fiber of that material and reintroduce it into the supply chain to create new garments. So there's a wide range of applications of circular economy in different industries, and many of which are in the built environment as well. And we know that just in the construction industry, if we start adopting circular economy principles, we can increase the construction industry's productivity, and we can therefore save about $100 billion a year. So that's quite significant. The other motivation in using circular economy in the built environment is that we still have about half of all infrastructure systems that we'll need by 2050 hasn't been built yet. And so raw material consumption will double by 2060. So if we just continue to build how we're building using the natural resources that we will run out of gravel. We will run out of these natural resources. So we really do have to rethink how we design and build the built environment with this idea or this knowledge that resources or natural resources will become will decrease in availability. So in this flagship, what we're doing, and the PhD student working in this project is Gabrielle Lee, we're scaling up the concept of circular economy and applying them not just to, let's say, a project, but to communities and urban systems as a whole. And we're developing a series of use cases and developing interactive environments to also educate the public of what this means. What does scaling up circular economy mean? This is an example of a development in downtown Austin called the C Home. It used to be a power plant, so it's a C Home development. And you can see here from the image on the bottom left here that this grassy area in front of this old building here, that's a shell structure that's currently under development. This is a dog park, but under it there's a 325,000 gallon tank connected to a rainwater harvesting site. So they collect rainwater, and that minimizes the flow that goes into our river in downtown, and creating a buffer. So when we have an extreme weather event, let's say a heavy rain, we minimize what ends up going into the river with this green infrastructure in place. So Gabrielle has developed in partnership with Microsoft a mixed reality demo here that illustrates what this is, and people can interact and see this invisible infrastructure in an intuitive way and interact with it. So last year we got a major award from the Department of Energy, and this was again because of Planet Texas 2050. As a result of being part of that group, of interacting with so many individuals of different disciplines, we submitted this proposal for an urban integrated field lab in Southeast Texas. So this is one of 4 DOE funded integrated field labs. These are very large. So it's 17 million over 5 years. And we're the lead institution here at the University of Texas, but it's a multi-institutional project. So we have 6 different institutions that are involved in this UIFL. We actually just had the PI meeting in DC this week. Another reason why I couldn't be there this week is we had the PI meeting in Washington, DC on earlier this week. But the idea with this, we're looking at the impacts of flooding and air pollution in this vulnerable a set of vulnerable communities in Southeast Texas. So if you don't know, Southeast Texas is the energy hub of our state. There's a lot of refineries, petrochemical plants in that area. So there's chronic air pollution because of that. But it's also an area that's very flood prone. Many of the areas in that region are below sea level. When Hurricane Harvey hit in 2017, many of those areas were underwater, and more than 9 feet of flooding and storm surge is what they saw in that region. So that's why we're looking at that stress in between those two, flooding and air pollution. So the way that we structured this field lab is we have 3 main themes. So we have an environment theme that has all of our water and air and climate science researchers. We have our co-design team, which has researchers that are focused on designing climate resilient solutions alongside our communities. We're using a nonprofit organization that's helping us with all of the community engagement. And then we have our equity theme that is looking at all of this design and all of the implementation of these infrastructure systems from an equity lens. So where I'm heavily involved here. I'm managing the whole thing, but as I'm the project management lead for the entire field lab, but I also am a researcher in the co-design team. So my PhD student Sean Murphy is focused on designing climate resilient infrastructure systems, and Lynn, my other PhD student in this project, and postdoc Chi Shen, they're both working on the knowledge management platform. So this is this vertical line here that is focused on integrating all of these models, climate models, water models, air, field data collection models from the air team, into what we're calling the knowledge management platform. So we're developing that workflow, integrating all this data, which we can then use for scenario development of what the future states will look like. So we're heavily involved too with the Texas Advanced Computing Center in this research. So TAC is also part of our knowledge management platform team. And we're really excited about this project. We just finished we're wrapping up year 1, and we're about to head to Beaumont for our annual all hands meeting that will happen in about 10 days. We're all going to be over there, all 6 institutions. We meet annually in Beaumont. So a lot of people are involved in this project, and we have a lot of external stakeholders also involved, over 100 stakeholders. We have expertise at the University of Texas and with our partners at Texas A&M and our local university partner, Lamar University, that have this expertise in community engaged research, and we're leveraging that with Texas target communities to perform a lot of this work. So here's just an example of a case study that we worked on in this past year. So we're collecting terrain data, aerial terrain data, and this is going to be integrated with those flood models that are coming out of the water team that are then refined based on input data from the climate team. So the climate team is trying to get global climate models and downscale it into neighborhood scale, so we can have more refined flood models that we can then integrate to our terrain models of existing conditions with modifications of new designs that we're adding to that. So a lot of work has come out of this general circular economy theme of work that I've been doing, but of course many more papers are going to be coming out, especially now given this DOE project that we're focusing on, that we still have 4 years to go to complete that DOE project. But I just wanted to wrap up to make sure that we have some time to answer that any of your questions. So again, my research sits at the interface of engineering and computing. So I'm really interested in understanding what information is needed by the stakeholders, modeling and transferring that right information, right? What they actually need. So understanding that involves being engaged with communities, being engaged with stakeholders that are actually going to be using that data. So it takes a lot of trust building, a lot of time to be able to engage with the relevant stakeholders. But for me, my motivation is I want to be able to be performing research that is relevant to the people that are going to be using that research, or the people that will be impacted by the research. So even though it's not easy work, it's still I'm motivated by this type of work. My work is also driven by innovation. So I'm always looking at new technology, trying to look at what other industries may be developing that can be applied to our industry. I love interacting with different disciplines. And that's one of the reasons why now I'm doing a lot more cross-disciplinary research. I never thought I would be working directly with climate scientists from our School of Geosciences, or with social scientists that are focused on equity and thinking about how we ask our research questions, how we develop research questions with that equity lens in mind. So I have been challenged by my colleagues from other disciplines, and I have changed as a researcher as a result of doing research with other disciplines. So it's really a fun experience for me, as we all evolve, right? As part of as academics, we can always be reinventing ourselves and learning new things as we progress in our careers, and that's one of the best parts about being in this career. So I wanted to wrap up by saying thank you all for joining today. And again, I wanted to recognize my students that are really the stars of this show. And these are the people that really make me look good with all of the wonderful work that they do. And our model here, you can see from the top right-hand corner here of the slide at the university, is what starts here changes the world. And I really do believe that each and every one of these students are out there changing the world for the better. Thank you so much for having me today, and I'll be glad to answer any questions at this time. I'll stop sharing.
Yeah, thank you very much, Professor Leite. That was a very interesting presentation indeed. Let me open it up for Q&A. Anybody, I'm sure you have questions. Please open your mic and ask your question right away, please. Anybody can go ahead. There's no order.
Yeah. So I'm not sure if I can ask questions because I'm not actually officially the product person.
Go ahead.
Hi.
Hello, Fernanda. Yes. I have never thought about saying no when I was visiting Purdue, but I'm so glad that I can join this seminar. So Fernanda, it's a very great presentation, by the way. I'm always impressed by what you have been doing for this community. Actually, my question is, I think it looks like, considering your prior role for the center, it looks you have been working with many researchers from the different department. I think you're still, I think it looks like you have, so for example, you also said that you have never thought about directly working with the climate scientists, for example. Actually, my question is, I'm also working with the researchers coming from different departments, but I think one of the challenges that I'm facing is different researchers may use different languages depending on which disciplines they originated from. So my question is, do you have, I'm not sure if you also have, if you also previously had the similar challenges when you work with the researchers coming from the different department? If you do, then if you did, then I'm just wondering what would be the kind of the advice that you want to share with other researchers who are interested in working with the researchers from other disciplines.
That's a great question. So the first 2 years of Planet Texas 2050 was just us getting to know each other and understanding what we mean by model. I understand, I think of a model and I might think of a model of from an engineering perspective, but a geoscientist might think of a model as something different. Right. So the first 2 years, the leadership committee within Planet Texas 2050, we did a lot of I would say, mini seminars so we could understand each other and we could understand how to communicate and we could understand how we could collaborate. One way that we found that worked well, and we did this, we have 2 funded projects, two large, the DOE one is a more recent one, but we also have one that was funded by NSF Smart and Connected Communities. That's also 5 different colleges, or the 5 PIs are from 5 colleges in that project. So not even engineering, just within engineering, there are 5 different colleges in the university. What we found is that if we focus on a place, and that's the common ground, we're doing work on the same location. If it's a neighborhood, if it's a region, that helps contextualize the work and it makes it real because you're talking about the impact of that work in that specific context. And when we finally understood that, that's when things really started to make more sense in what we were doing. Because if you just stay in the abstract, it's really hard to operationalize and to begin implementing the work. But I think the tipping point for us was when we came to understand that we just had to figure out what is that common ground from a place that we can all work together in. And in the NSF Smart and Connected Communities project, we focused on a vulnerable community, one neighborhood here in Austin. That's a flood prone area. And in the DOE project, it's a little bit larger because it's Southeast Texas. So it includes 2 cities in Southeast Texas, but still there's a very specific context that applies to that area. You can replicate it broadly, but I think if we start somewhere in a specific context, in a specific area, that really, really does help.
Yeah, thank you.
Thank you, Jiyoung, for that question, and of course, Fernanda. Anybody else?
I have a question, Professor.
Yes, EJ, please go ahead.
Hi. Thank you for the great presentation. I'm a PhD, third-year PhD student in civil engineering. I have a question on your huge point cloud data set. I read some paper from your lab, and I think it is so nice to have such a huge point cloud database on building elements. And I have a question on what do you think of monitoring moving objects? So the database you created is like a static object, right? But I think a depth camera and LiDAR has the benefit for getting the volumetric information of the object. But I think even point cloud requires some high computational load. But I think the expense of computation and the storage will be reduced in a close distance. So I am thinking of monitoring moving objects using depth camera or LiDAR. I want to know, what do you think of this?
Yeah, so I agree with you. I think that if you think of Moore's law, right, and we're seeing that's not going to be the amount of computation we have in our smartphones today is a lot more than what I had in my laptop computer as a PhD student when I was a PhD student at Carnegie Mellon, right? So I can do a lot more just on my phone today as compared to when I was a grad student.
Yes.
And that's going to continue to grow. So I agree with you, and that's one of the reasons why we're trying to now, the new version of our data set that we're launching next year will include 3D objects. So instead of 2D projections, we're working on 3D data. But we haven't done what you're talking about, which is moving objects. And that would be quite interesting to see. What I would think about in terms of dealing with that is, how do you process that data remotely? So you might have access to, let's say, if you have access to a supercomputer at Purdue, or even a small rendering farm, that might help optimize that processing time as well. So I would consider looking at high performance computing approaches. Parallel processing would be one of them, to be able to make that computation quicker. Because if you're working on the cloud, you still have to optimize how you deliver that data. And I would look at high performance computing work, and there's lots of work in that area. So the aerospace industry has been doing a lot of work in digital twins, right? And using objects that move and modeling that, which we can then apply to the built environment as well, to what you're talking about in moving objects. So I would look at that at work in high performance computing and parallel processing to see if that can help.
Thank you so much. It
No.
really helped.
Thank you, Ajay. That was a good question indeed. Anybody else wants to go? Please open your mic and ask your question. Ali,
Hello.
go ahead.
Hi, this is Ali. I'm a PhD candidate at the construction engineering department. So the thing is, I had a question about the Beaumont project. You mentioned that you're considering equity, and I was wondering how that is operationalized, considering that do you treat all people the same, or are you considering, do you know the amount of tax money that they're paying, maybe at the zip code or district level? The question is basically how to operationalize equity.
Yeah.
Independent.
So I'm not in that group per se, the equity group. So I'll give you a high level perspective of what they're doing. So one way that we're operationalizing that is, we're working. All of these teams are integrated. So the water team is implementing sensor placement to monitor air quality and monitor flooding. One thing that we've noticed is that there are typically more sensors in areas that are not as vulnerable, or of higher income, middle class communities. And that there's lots of research in this area. There's a researcher at Berkeley called Josh Apte that does this air quality research. And he also has been looking at that in terms of sensor placement for a systems modeling. It could be, in his case, it's air quality modeling, that tend to be placed in areas of wealthier communities, right? So we get more data. So let's call it data-rich communities, right? But we really, from an equity standpoint, we need to understand, and we know that from a planning standpoint, usually vulnerable communities, lower income communities, are placed in areas that might be where the wind typically blows, and they get a lot of that polluted air from the industries, but they're not monitored. The air quality is not there's less sensor placements in that area. So they use a structured approach to identify what vulnerability means, and this came out of and I can't remember the name, but it's a different university. I believe it's in the Carolinas, but there's a social vulnerability index. So that's a structured approach to identify, based on a location, how vulnerable that group of people are, and based on census tract data. And so we're looking at trying to put more sensors, monitor more in those areas that we identify as socially vulnerable areas. And we're sort of trying to be careful with the language that we use. I don't think that we're actually trying to move away from the term socially vulnerable, but we're trying to come up with another term there, because it's not it's not by choice that they are in that situation, those communities. But that's how we're doing that, and how we're trying to understand where they are and what we can do in terms of change by collecting more data to help co-design more equitable solutions for those communities that are most in need. So the way that we think about it is these communities, vulnerable communities, they tend to already suffer from chronic stressors. It could be food insecurity, poverty, and in this case, air pollution. And so when an acute stressor event happens, like a hurricane, those communities that have already suffered from chronic stressors tend to have the hardest time bouncing back to their previous state, right? And that's what we're looking at. We're really, really focused, and that's why we decided to focus in Southeast Texas, because our focus is on those acute, on chronic stressors. I hope that answers your question.
Yes, that was indeed an interesting answer. I mean, just basically having them in radar, that's the first step. And that's amazing. Thank you so much.
Thank you, Ali. Professor Widener, you had a question.
Yes, thank you. I appreciate the presentation. It's very interesting. I was wondering, since I have been doing a lot of research and study in automating of analysis of different things, I was wondering if you have discovered any kind of loss of what I would call sort of the gut feel of what's happening in a project by automating as much as you have. Do students still pick up sort of the gut feeling, gut engineering issues associated with the complexity of buildings that you are studying as the automation techniques, as the visualization techniques improve?
That's a really great question. So the way that I see technology being used, it's another layer, right? So if you're implementing, for example, safety, automation, and identifying an unsafe situation, that cannot be the only thing that you can rely on, that you should rely on. It's an additional layer that can help in decision support. So we all have to really understand the context in which we're making that decision, because ultimately we as PEs, as professional engineers, we're making those decisions. And we have to justify why we're making that decision. So the way that I see technology is that they should serve as decision support and not automatically making decisions for us. So we're using that as an additional piece of information in the entire context of the project, because I agree with you, projects are very complex and it's hard to simplify into one. Usually when we automate something, it's a very small process that we're trying to automate. That's what machines are very good at, but that's one piece of the larger puzzle of the entire project, and we can't oversimplify that because it's just quite complex. So it's a piece of the puzzle that we can leverage in the decision-making process.
Thank you, Ted. Anybody else?
Hi, Fernanda.
Yes, Jinsan, go ahead.
Thank you, Mark. Thank you for the great presentation. It's good to see the more recent development of your projects. Congratulations on those larger projects. And I have a quick question of the 6 flagship projects, because especially one of them is called the Equitable and Regenerative Cities in a Post-Carbon Future, which is the one that you are leading. Mm-hmm. And then there's another one, which is called Networks for Hazard Preparedness and Response. This is actually the first time that I ever heard of the term regenerative cities. So I did a quick search on Wikipedia, and it is saying it's not only about minimizing the environmental impact, but actively improving and regenerating the productive capacity of the ecosystems from which the city depends on. So I'm curious, like earlier you have provided some examples. Let's say when the hurricane hits, the communities are going to be impacted, which seems to me more in the hazard preparedness category. So I don't know what is the main distinction between these two areas. Yeah,
That's
yeah.
a great question. So I agree with you. I think one is more in disaster preparedness and response, and the Regenerative Cities flagship is more in circular economy. That's what we're doing to try look at implementing circular economy at the urban scale, at the building systems, at the urban system scales, like water. How do you implement circular economy in water systems? How do you implement circular economy in energy systems? And this is not done by smaller groups of people. We typically have researchers that are energy researchers, and they're trying to think about, okay, how do we think about energy systems in a circular way? And then water researchers, how do we think about water systems in a circular way? So the cool thing about Planet Texas is we have the resources to be able to bring on board a lot of other researchers that have different types of expertise, and we can have them think creatively of how can they implement or rethink how that system that they are focused on can be implemented or done under that circular economy framework. So that's the idea. The Regenerative Cities flagship is all about circular economy at the urban scale.
Great. Thank you so much, Fernanda. That helps a lot. So if I understand correctly, that means let's say from the water perspective, the regenerative cities is more looking at how the water resources can be, let's say, reused and recycled, whereas the hazard preparedness project may look more into like when there's a hurricane, how those maybe water supplies may be disrupted, things like that, right?
Yes, or how can we proactively co-design climate resilient infrastructure systems that could better protect our vulnerable communities?
Gotcha. Thank you so much. So another related question is, how do you usually develop these type of themes, for those larger, flagship projects or, like research center, these type of things?
Well, I think that the best thing is to look at problems, right? So in Southeast Texas, for about 20 years, there's a group called the Flood Coordination Study. And sometimes listening to community members and listening to the problems that they live and that they are really great ways to just identify ways that we can help as researchers. So a lot of what we do in Planet Texas 2050, and that's part of what the Office of the Vice President of Research helps us with in community engagement, in events that we put together, is listening to communities. It's visiting communities. It's seeing what problems that they're living day to day. And that's providing us with research ideas of what we can do as researchers to help them in an impactful way. So I would say that's what I mentioned, that community engaged research is hard and it takes a long time, and building trust is something that's time consuming, but then you can come up with these really cool ideas that you really feel that you can change people's lives.
That's awesome. Thank you so much, Fernanda.
Thank you, Professor Zhang. Anybody else wants to go next? You can open your mic and ask question directly. Yes, Professor Kai, go ahead.
Hey, Hugo, good to see you.
Thank you, Mark. Hey, Fernanda, good seeing you. I'm sitting in a public event, so I'm trying to just stay in the quiet mode. Thank you very much for the presentation. It's an excellent presentation. I really love the way you said that you're working on research that can actually generate something that is practical and usable back to the stakeholders. So I know you have done extensive, long list of projects in that aspect. And I'm just here to ask if there's anything that you can share regarding the way you communicate with the stakeholders. Which kind of methods works the best, which kind of method probably are getting a little bit tied out as the process goes.
Yeah, I'll give you a couple of examples. So we've used different approaches, right? We've used Delphi method, but Delphi method is you don't really engage heavily with people, right? It's almost like a structured surveying approach of experts in a group. You can do surveys, you can do semi-structured interviews using qualitative coding, but I think that the most meaningful one that I've seen so far is is in the NSF Smart and Connected Communities project, we've developed a program called the Climate Navigators Program. That's a citizen science program. So we train with a nonprofit organization. I think that's for us, once we learn that if we can partner with nonprofits that are part of that community, that have already done the difficult work of building trust with those community members, and we're coming in and partnering with them, that has given us the biggest success. And we did that in both this NSF Smart and Connected Communities project, in which we partnered with a local nonprofit called Go Austin, Vamos Austin, GAVA. And in Southeast Texas, we're partnering with Texas Target Communities. And so in the NSF project, we developed the Climate Navigators program that we're training the neighborhood residents to be able to provide information that can refine our flood models. So we're building a system with the Texas Advanced Computing Center that they can basically snap a photo, and it's geolocated, so they can tell us, oh, this part of the street here always floods when we have a heavy rain, or this part always there's water backing up in this area. So we can start collecting more data that feeds into our used by our water researchers. So that Climate Navigators program was organized and implemented with our nonprofit partner organization. So a big chunk of our budget for that NSF project was for that program, and was to compensate those community members that were part of that program, to train them. So I think that one of the big things is recognizing that it takes time for people to participate in that research project. So compensating them is important. And we're doing the same thing with the DOE project. We're also compensating all of our residents. We're creating committees that they're part of, and so that we can engage with them in the longer term. And it's all managed via these nonprofit organizations that have experience with community engaged research, because we traditionally don't, right? And a lot of people in our field, I know Hubo and Jung Song, we're computing people, right? So we're used to dealing with computer models, right, and not other humans. So I think we can learn a lot from people that have been doing this difficult work for so many years, and partner with them in our projects.
Thank you, Hugo. Well, we have time for maybe a couple of quick questions. If somebody has pressing questions to ask, please open your mic.
If I may just follow up.
Sure.
Yes, go ahead.
No, thank you, Fernanda. You mentioned, like, for these community members, you may compensate them. Do you mean compensate them with, maybe some like gift card, or just
Yeah, in our case, in the NSF project, we actually give them gift cards, because that's how we're able to do that with a grant. So usually it's in the form of gift cards. And if we have, for the Beaumont team, if we have to move people around, we cover all of the expenses. We also compensate them for their time as well. So we have a significant portion of the budget for that, to compensate our participants. Okay, that's great to hear. So also, I mean, from the logistic point of view, how do you compare a DOE project to an NSF project? Because I never engaged in a DOE project before. There's a lot more reporting requirements, I can tell you, and they are a lot more involved. And there's a lot of requests that you get. So we in the DOE project, we actually hired a program director that helps us manage the entire project, because it's so large. There's 29 co-PIs in this project in 6 different institutions, and just managing the interfaces between all of the different themes is a lot. So we hired a full-time managing director that does that work for us, and manages all of the requirements with DOE. So there's, from a management standpoint, it's quite complex, but I enjoy that. I was the one that wrote the entire management plan for the DOE project, because I enjoy putting together large complex organizations and how they're going to operate. But we needed somebody hands-on that that's their full-time job is to do that. And that's what we did in this in DOE project. In the NSF project, the Smart Connected Communities, it's not as large, of course, but we ended up partnering. It's a matter of identifying what expertise you have and what you need to partner with. So in that case, we partnered with a local nonprofit for the community engagement piece, and we also partnered with TAC for the system development piece. So I think it's a matter of understanding who has the right expertise so you can put the best team together to do that work, right? Because we can't do everything, and oftentimes a lot of the barriers that we see is sometimes we think we can do it, but then we don't progress as quickly enough, because if we're only relying on, let's say, hiring one PhD student that will take a while to be onboarded and learn those skills, the grant is over, right? So sometimes we need to move a lot quicker. So hiring the people that already have those skill sets and the groups that already have those, so we can hit the ground running, really helps us progress quicker in research.
Got it.
Great.
Thank you so much.
Yeah, thanks, Jinsung. Well, we have run out of time. So I will use my moderator privilege to ask the last question, as I always do. So, Fernanda, a very interesting presentation, and you can see from the set of questions that we got that everybody is really engaged in these topics. You talked about circular economy, and whenever I've been engaged in these kind of conversations, the topic always comes up that construction industry, for example, how big a circle should we be responsible for? And so if we are committed to circular economy, how wide of a supply chain should we be engaging with to make it happen?
Yeah, that's a good question. So in the CII project that I led, that we reported on last year at the annual conference, we did a global scan of 81 companies that are already implementing circular economy in the built environment, and that ranged in terms of size of companies and what they focused on, what their business model was. So an example is Caterpillar. So everybody knows Caterpillar, the equipment manufacturer for the construction industry, those big, heavy yellow trucks, right? Caterpillar has been very successful in implementing circular economy. They just changed their business model. So instead of buying a piece of equipment, you lease it from them. So you use it, you lease that equipment. Whenever it breaks down, you call Caterpillar, they come up and just give you a new one, and they take that back, disassemble it, and reintroduce those parts into this circular economy. So in a way, we can begin thinking about a project as a system of systems, right? Another example is carpet manufacturers. Carpet manufacturers, instead of owning or buying carpet, you can lease it, and once it's damaged enough that you want it exchanged, the company will come in and put in new carpet and take that old carpet, reintroduce those fibers into the supply chain. So we have to start thinking about how do we do that how do we break down the built environment into these systems that we can think about in a different way of not owning, but using the service of that system. To do that effectively in the long term, if you think about a building, an entire building, we have to think about designing in a different way. And that's one of my current PhD students is focused on. And he worked in the CII circular economy project, but his PhD is actually on design for disassembly. So you have to proactively start thinking about designing in a way that we can disassemble a structure so that you can reintroduce those pieces and parts into new structures and to new pieces, right? So lots of challenges involved in that, but there's a start, right? If we need to learn to break down our systems, our product, our big product, which is composed of a bunch of smaller products, we need to start thinking about it at the unit level of how to implement circular economy at that unit level.
Thank you, Fernanda. Well, thank you everybody for being part of this seminar. And of course, to Fernanda Leite for this very interesting presentation. We really appreciate you taking time out of your busy schedule. So let's open our mics and give her a big round of applause for doing this.
Thank you. Thank you all for having me. It's my pleasure.
Thank you very much. And please
Thank you, Fernanda. Thank you, Mark.
Please stay tuned for the next week's seminar. You know that the theme is women researchers in the built environment, and we have a long list of excellent researchers coming the rest of the semester. So with that said, thank you all. Have a great day. I'll see you all next week.
Thank you, Fernanda. Thank you, Mark.
Bye.